credible. In the sense, ultimately your data must be accurate, right? Accurate means the measured value is close to the true value, right? Now, what is the time right now?
12:16, sir.
12:16.
12:16. And if I look at the true time is also 12:16, and the observation is also 12:16. My data is accurate now, isn't it? How do I understand accuracy? Because there is no bias in the reading. What is bias? The difference between the measured value and the true value. True time is 12:16 and the measured time is also 12:16. So there is no difference. The bias is zero. Whenever bias is zero, your reading is accurate. Imagine the bias is not zero. Let us say the time is 12:16, but your watch is showing 12:26. That means your watch is now running fast. Your watch is 10 minutes faster. This 10 minutes is called a positive bias.
Yes.
Do you think such watch is useful, still usable?
Yes.
Sometimes we use, right? Because we are very clever. We always subtract 10 minutes and then find out the right time. This is called data calibration. This is called data calibration. As long as the bias is stable, you don't have to worry. If the watch always runs 10 minutes faster, you don't have to worry because you have a way to fix it. What is the way? You subtract 10 minutes every time you get a reading from your watch. Yes or no? What is this process known as? Data calibration. But sometimes, if your watch is under such condition and you don't take the right action, slowly it will start behaving in a dynamic manner. Isn't it? Instead of bias remaining stable, it will become very dynamic. If the bias becomes too dynamic, will you be able to find out the true time by calibrating the data? No. That's the time you will realize and take your watch to the nearest service center, isn't it?
Yes, sir.
Yes.
We'll go to the service center, and that fellow will now change the battery and see whether any component has worn out. Maybe some spring or something he will change, and now your watch will start running in a bias-free manner. This is called equipment calibration. This is called equipment calibration. Earlier it was data calibration, but now it is equipment calibration. And now you realize your watch requires some attention at least once in 6 months. You get your watch serviced or at least the battery changed once in a 6 months, isn't it? This is called calibration frequency. This is called calibration frequency. You must have an idea about the frequency of calibration because bias-free reading means accurate reading. Accurate reading means accurate statistics. Oh, is there a connection instability?
Clear.
Clear.
So readings accurate. So statistics are accurate, and that means your predictions are accurate, isn't it? And so that's why our data is important. So if your bias is stable, very good, you can calibrate your data. If bias becomes unstable, then you have to calibrate your device. I think now all of you know how to deal with the bias, right?
Yes, sir.
So by all means, the bias should be minimal or zero. The bias should be minimal, bias should be constant, and bias should be zero. And the remedy is calibration, understanding the right frequency of calibration, and then proper maintenance of your measuring instrument, and then having a clear procedure of data collection. That is known as operational definition, right? If the operational definition is very confusing, do you think people will bring data, error-free data?
No.
Anything you explain, the other person should be able to understand in the right manner, isn't it?
Yes.
If that is not happening, the problem is not with the other person, the problem with your operational definition. Have you discussed about operational definition? Yes or no?
Yes, sir.
Yes, sir. Previously we covered.
Previously only, that's what I'm recalling, previously, right?
Yes.
Operational definition, a clear and concise statement about what is to be observed and what is to be measured. A clear, concise statement about what is to be measured and what is to be, what is to be observed and measured. People should have a full clarity on how to measure. Otherwise, what happens? If you ask somebody to measure the weight, do you think they will measure the weight correctly? If I want all of you to measure your own weight and bring the reading tomorrow, do you think all of you will measure correctly? We all know how to measure our weight, right?
Yes, sir.
If we are
Yes.
really concerned about accuracy, there has to be a proper way of measuring the weight, isn't it?
Correct.
Yes.
Correct.
Like
Everyone
imagine
should report in kilograms uniformly.
all of us should, okay, first definition comes. All of us must report in kilograms. Very good. What else needs to be taken care?
Machine should be calibrated.
Oh, device must be calibrated. Okay.
Use
you should-
calibrated instrument.
You should not wear any external accessories like
What you want to
slippers or what.
Oh, you
Fix the time of
okay.
measurement.
You should not wear any external accessories, right? But your shirt and pant is okay. But shoe and other things you don't want to wear, right? Very good. Good point. Very good.
Your
the-
eyesight must be good.
What should be good? Eyesight.
Eyesight vision. For
Oh,
taking
that is required for weight measurement.
the reading. Correct.
Oh, for taking the readings, right? For taking the readings, you are saying.
Yes, sir. Yes, sir. Yes, sir.
Is it before or after eating food that we are going
Yeah.
to?
Whether you should take the weight with empty stomach or after your breakfast. See, do you now understand the importance of operational definition? If we don't have an operational definition and expect all of you to measure something tomorrow, do you think all of you will measure correctly?
No.
You all will be inaccurate. There will be a lot of inaccuracy, isn't it? You will be reporting the data with a lot of inaccuracy, which I can call it as a bias. And moreover, your readings may not agree to each other. Even though all of you are measuring the same thing, still there is a chance that you can disagree with each other. If you disagree with others, then you are committing an inconsistency, an error of inconsistency. Error of inaccuracy, you understand by looking at bias. Am I right? There is an error of inaccuracy. There is an error of inconsistency. Whenever you make people to measure repeatedly, there is a chance for inconsistency. That is what is called as repeatability error and reproducibility error. Am I right? You have studied?
Correct.
Yes, sir.
If I
Not
ask you to
achieving
measure,
precision is repeatability and reproducibility problem.
yeah. If I ask you to measure a particular reading multiple times, same thing again and again, then all your readings should be same. But in reality, it will not happen. If you measure something repeatedly and bring different readings, the error is known as repeatability error. You are not able to repeat your reading, isn't it? Even though the characteristics is same, measuring instrument is same, operator is same, but readings are different. This error is known as repeatability error. If I involve multiple operators and they don't work consistently, they are not aligning with each other. Procedure is same, characteristics is same, measuring instrument is same, but what is the difference? Operator is different. Now readings are not aligning. There is an inconsistency. This error is known as reproducibility error. Understand all of you?
Yes,
When
sir.
I say repeatability or reproducibility, this is error due to inconsistency. When I say bias, that is error due to inaccuracy. Inaccuracy means bias. Inconsistency means repeatability error and reproducibility error. All right. In order to minimize this bias, we always take multiple readings, isn't it? Because our goal is ultimately bias should be minimum. Ultimately, bias should be minimum. That's why we take multiple reading. Yes or no?
Yes, sir.
Otherwise, we don't have to take multiple reading, right? So, in order to minimize the bias, we take multiple reading. But the problem with multiple reading is chance of inconsistency, isn't it?
Yes, sir.
So that inconsistency should also be controlled. That inconsistency should also be controlled. For that, you already discussed a tool known as attribute agreement analysis. Am I correct?
Yes, sir.
Which is applicable if your data is attribute data. Yes or no, good or bad, accepted, rejected, okay, not okay. In all those situations, you should perform AAA. What does AAA stand for? Attribute agreement
Attribute
analysis.
analysis. Attribute
Where you measure something known as team accuracy. The team accuracy must be minimum 90%. If it is in the order of 70 to 90%, conditionally acceptable. If it is lesser than 70%, unacceptable. This is true if your data is attribute. But if your data is continuous, then we have another tool known as gauge R&R. We will deep dive about gauge R&R in the next week, right? But now I would like to just let you get a feel of how the repeatability error will come, how the reproducibility error will come in the case of continuous data. You all know the difference between continuous data and attribute data, right? Attribute is yes or no, okay, not okay, right? That is attribute. But continuous
Yes.
data is measurable. And now every equipment, every measuring instrument, it has got something known as least count. Am I
Yes,
correct?
sir. Yes,
What is
sir.
least count? What is least count? The lowest signal to which,
Lowest
to which your instrument can respond. The lowest signal to which your instrument can respond. Now tell me, in your wristwatch, what is the lowest time you can notice in your wristwatch?
Seconds.
Only seconds. If you go to a stopwatch in your mobile phone, you can even go further finer, isn't it? Even after seconds, you can go for 0.01 second also. Yes or no?
Yes.
Yes.
sir.
So this is called resolution or least count. So what is the least count? Your normal wristwatch, least count is 1 second. But in your mobile phone, there is a stopwatch. What is the least count of the stopwatch in your mobile phone? All of you just check your mobile phone, open your stopwatch and find out the resolution or the least count. If the resolution is poor, then error will be more. Are you checking, all of you?
Yes, sir.
I see only few of you participating.
Millisecond.
Milliseconds.
Yeah, you can use the units if you are sure about it, right? Are you sure it is milliseconds?
Actually, it's not a millisecond, the point second.
So always be on the safer side, right? Be on the safer side. Otherwise, what happen? Your data will lose its credibility, right? So what is millimeter, 1 millimeter? We all know, right?
10 millimeter equal to
one tenth of
10 millimeter equal to 1 centimeter.
1 centimeter.
And 100 centimeter is equal to
1 meter.
1 meter. So how many millimeter is equal to 1 meter?
1,000.
1,000.
So if you break 1 meter into 1,000 pieces, then each piece is 1 millimeter, right?
Yes, sir.
Very good. Here in your stopwatch, 1 second is
100.
divided into 100. So you can't call it milliseconds. It is better, safe to call it as 0.01 second.
Yes, sir.
Or otherwise, if you want to, that means you are dividing a second into 100, right?
Yes, sir.
Divide 1 meter into 100, then each unit is known as 1 meter into 100 pieces. Then each piece is centimeter.
Centimeter.
So here also you should call it centiseconds. Otherwise, safely 0.01 second. So the resolution of our stopwatch is 0.01 second. I am going to do a small exercise. I want people to come on video with the stopwatch in hand, right? Like your stopwatch. Let's do a small exercise to understand how repeatability and reproducibility happens. Error will populate. All of you agree?
Yes, sir.
Always error will populate. So we must try to control it. Try to control it. See to that it is lesser than 10%. If it is more than 10%, data is not credible, right? So that's the thing. What am I supposed to do? Any guess?
We can have one operator recording all the transactions.
One operator, only one operator only you want to involve, right?
Yes.
Okay. But in reality, it is not possible. Can you do
Instead
the
instead of employing human operators, we can automate the data collection.
Yes.
that is a good idea. Okay. You can automate. See, that's the ultimate. Ultimately, we want to do that, right? Ultimately, there will not be any humans in the earth. That is also going to happen one day. Right? Possible. So we want to automate and minimize the human intervention as much as possible, because humans are prone to commit some error. So we want to minimize that. Very good. So, but that is not going to happen immediately. It will take time. So now what can be done? Like, you need to improve on the operational definition, isn't it? You need to train your people on how to collect the data.
Yeah.
Some training is
Yes.
required. And at the same time, you can't say, I will only use one operator. No. If whatever is possible in the real scenario, that only you can do, isn't it? So,
Different start and stop criteria.
yeah, come again.
Accurately define when to start and when to stop.
That's called operation definition. Yeah, that's called operation definition, right? So all of this, you need to take the right action. Thereby, your readings can become more and more accurate. So with that,
And there is some network error also.
what is that, sir?
Steady network.
There is network because we are using different network and their response is little bit in few microsecond plus or minus. That also resulting.
True. That is very, very true. That means you wanted to, even you are now talking about the environment under which you take the reading.
Yes.
Right?
Correct.
We can
all that you need.
also introduce standard operation procedure, like how, so everybody will have a set of rules and regulations, what they follow and how they collect the data.
Yeah. Here we don't call it SOP, we call it operational definition.
Yeah.
We call it, but same, right? It's operational definition. So the error due to inaccuracy is bias. The error due to inconsistency is known as precision error. The repeatability error and reproducibility error put together is known as precision error. What is the amount of precision error in comparison to the tolerance range given by the customer? This must be lesser than 10%. This must be lesser than 10%. Imagine you are working on a CTQ characteristics, let's say 100 microns. 100 microns is the, dimensional requirement given by the customer, plus or minus 5 microns. So what is upper specification here? 105 microns. Lower spec, 95. Now how much is the difference? 10 microns, right? And 10% of 10 micron is 1 micron. Any reading that is coming out of your measurement system should have a error lesser than 1 micron. That is the meaning of having a gauge R&R lesser than 10%. Your gauge R&R, if it is lesser than 10%, your measurement system is good and acceptable. If it is in the order of 10 to 30%, conditionally acceptable. If it is more than 30%, never accepted. So we will deep dive the next week, right? How to control further. And in order to control, what are we supposed to do? Can we do something with the collected data to understand what happened? See here, this way you can collect data. And in data collection also, there are certain, best, good practices you need to follow. All of this we will be talking in the next week, right? And some of you, if you really wanted to upgrade your understanding on that, yes, without delay, you need to take some action, and so that you can be part of the next week. All right. So now I want to take you through another important tool, the last tool in the measure phase, process capability indices. Process capability indices, CP and CPK. I already touched on it, CP, CPK, but now we are going to little deep dive. So, any of you familiar with CP, CPK? Are you using it in your workplace? Manimaran is using, right?
No.
You are not using.
No,
But
sir, no, sir.
yeah, do you think all the tools you are learning, you will be able to use in your workplace?
As per the situation, sir.
Depending on the requirement. See, your company might be using the same tool, and so you will feel much happier now. Oh, if the company is using Pareto, now you learned Pareto here. But some tools your company may not be using, but you might be learning here. Now, what to do with those tools? You need to understand the context in which the tool becomes more appropriate, isn't it? If the similar situation happens in your workplace and your company do not know about the tool, you don't have to keep quiet. You can use the right tool, isn't it?
Oh, yes.
CP, CPK, even though if your company is not using right now, don't worry about it. If people know it, they will use it. If they don't know it, no, that is a lack of knowledge. They are not using it. It doesn't mean that you should not use it. So CP, CPK is a tool used to measure your process capability when your data type is continuous. Whenever your data type is continuous, you can use the tool CP and CPK. Please tell me, are you using any continuous data in your workplace, in your analysis? Are you using any continuous data?
Yes.
Yes or no?
Yes.
Are you measuring cycle time, lead time,
Yes.
call handling time, average handling time, isn't it? And
Yes.
diameter, length, surface finish, claim reimbursement time, salary processing time, isn't it? All
Yes.
of these are continuous data. In all these scenario, you can use the tool CPCPK, right? So don't worry if some of the tools are not currently used in your workplace. Still, if the situation requires, you can use it. But one more thing you all have to understand, ultimately all of them will take you to the same understanding. Please note, we have taught you DPMO, isn't it? And some companies use PPM. Some companies use defects per 100 units. Defects per 100 units and defects per million opportunities are more or less same, isn't it? We measure with respect to opportunities. Some company, they measure with respect to number of units. PPM is also with respect to number of units. Number of units is different, number of opportunities is different. Yes or no?
Yes.
With respect to opportunity, it is DPMO. With respect to units, it is PPM. So ultimately, finally, all of them will take you to the same level. Sigma level also tells the same thing. Your, what you call yield rate. You have studied yield also, right? Right? First pass yield,
Yes.
traditional
Mhm.
and the throughput yield. All of them is finally letting you understand your success rate and failure rate. If DPMO is minimum, failure rate is minimum, success rate is high. If yield is more, success rate is high, rejections are less. If sigma level rate is high, failure rate is low. If CPCPK is high, success rate is high. So all of them finally lets you understand only one thing, the chance of success and the chance of failure. Am I right?
Yes.
Accordingly, you take a decision, right? So now PCPK. CPCPK are known as process capability indices. The formula you already measured CP. You see here same formula. SL minus LSL divided by 6 sigma. You know why 6 sigma is written instead of UCL minus LCL? Because the distance between UCL and LCL is equal to 6 sigma. Right? And here sigma is nothing but standard deviation. And now there is one more metric introduced in addition to CP. Because CP has a limitation. Because CP has a limitation, CPK is introduced to overcome the limitation. Right? So CPK is known as process capability index. In order to calculate CPK, you need to calculate this CP upper, CP lower. There are two values you calculate. Out of the two value, whichever is the lower value, that is considered as CPK. Right? And now let's understand. Now look at my process diagram and tell me, is this process capable?
Yes, sir. Capable.
Capable. You are seeing the control limit well inside the specification limit. Process is capable. And for a capable process, if you calculate CP, it will be more than 1. For a capable process, if you calculate CP, it will be more than 1. And AIAG, the Automotive Industry Action Group, they have given a guideline. CPK should be 1.67 minimum. 1 makes you just capable, but we all know in a long run, long term, something wrong will happen. So more than 1 is always required, isn't it? Your monthly expense is 50,000. You will always search for a job where the salary is more than 50,000. Otherwise, survival is a question mark, isn't it? So same manner, we need more than 1. And the prescription is 1.67 if the characteristics you want to control is very critical. If the characteristics you want to control is very critical, then it should be minimum 1.67. If it is less critical, 1.33 is okay. If it is less critical, 1.33 is okay. So depending on the CTQ and understanding the criticality, the conditions needs to be fulfilled. For critical characteristics, what is the appropriate value for CPK? 1.67. For less critical, 1.33. So now this process is capable when I calculate with the values available here. See here, control limit 46, upper specification limit 50. Similarly, on the left side, I understand my CP is 1.67. For the same process, if you calculate CPK, CPK will also come at the same value, 1.67. Why both are same, CP and CPK? CP and CPK will be same if the process is centered on the target, or if the process is centered properly, you don't have to calculate CPK. But imagine your process getting shifted. Now the process is capable or not? Do you think the process is now also capable?
No. Yes.
No. There is a rejection here. Can you see this area? All the products here are outside the spec. That is going to be rejected. But even in this situation, when I use the formula CP, it is still giving me 1.67. Can you understand the limitation? The limitation is CP is not able to understand the process shift. Whether the process is shifting to the right or left, it doesn't understand. It only able to measure the variation. We always look at two things. One is variation, another one is central value. So the average should also be included in your formula. That is the reason why CPK is introduced. All of you understand now why CPK? If shift is not happening, CP is enough. But if the shifting of the process is expected, then CPK is required. And look here, the specification width is, I have divided into 2 parts. Can you see here? The entire specification width is divided into blue bar and then green bar. Well, I divide it in a way that they are equal. Right? They are equal. And similarly, the process width is 6 sigma. That also divided into 2 parts. So 3 sigma on the right side, 3 sigma on the left side. If a process is not at all shifting, then the ratio of the blue bar compared to the 3 sigma, ratio of the green bar compared to the 3 sigma will be equal. Am I right? If my process is shifting, now what happens to the blue color bar? Reduces. That means my risk of producing unacceptable products on the right side has increased. Whichever side the drop happens, that side my risk is more, because now my process is approaching one of the specification. That should not happen. My control limit is trying to go beyond a specification limit on one side. I don't want that to happen, right? So that's why CPK is introduced. Whether my process is shifting or not, I could see that. See here, now you can calculate two ratio. One is CP upper, which is blue bar divided by 3 sigma. Another one is CP lower, which is green bar divided by 3 sigma. Look at the formula. Blue bar length is USL minus X bar. And green bar length is X bar minus LSL. Can you see the ratio here? USL minus X bar by 3 sigma, X bar minus LSL by 3 sigma. Now I get two different values. Which is the smaller one? 0.833.
0.8.
The smaller one must be assigned to CPK. Now this CPK is the real measure of the capability, not the CP. When I calculate CP under the same condition, it will work out to be 1.67. It doesn't mean that your process is capable. CP gives a wrong estimate of the capability when your process is shifted. So don't use CP when your process is shifted. Or it is always better to use CPK and not CP. Is my suggestion correct? It is
Yes.
always better to use CPK and not CP, because CP has the additional potential to check whether the process is shifted or not. Process shifting also CPK will predict. If the process variation increases, control limit goes out, that also it will predict. So CPK is the best measure of capability than CP. Now, how to take decision? Always look for CPK. Minimum how much required? 1.66 or 1.67. If it is more than 1.66, you can immediately conclude your process is capable. But whenever it is less than 1.66, yes, it is not capable. But why it is not capable? There are two possibilities. Either the process is shifted or variation has increased. I don't know, right? So both possibilities are there. But CP, when you come to CP, if CP is more than 1.66, it means your process is narrower. Even a narrower process can still fail. Am I right? Even though you have a smaller car,
Yes.
there is a possibility that one day you can park your car in your neighbor's house. And then there can be a problem, isn't it? So, even though your process is narrower, the average should be on the target, isn't it? So, CP, if it is more than 1.67, you safely conclude that your process is consistent. Don't conclude as capability. Am I right? Whenever you are happy with the CP, then immediate conclusion is process is consistent. Whenever you are happy with the CPK, now the conclusion is your process is not only consistent, but also capable. Clear? Understand? If CP and CPK are same, you have reached the ultimate potential. If CP and CPK are same, you have reached the ultimate potential. Whenever you see CP higher than CPK, that means you can immediately understand there is further opportunity for improvement exists in the same process. Do you understand what I'm speaking? Whenever you see a CP higher than CPK, now the process is telling you, gentlemen, please improve me further. I can give you much more better result. So with the help of the CP and CPK, you can take all of this decision. Whenever your CPK is lesser than 1.67, then you can understand either the average is shifted or variation has increased. Now let us do a small exercise, all of you, before we'll shortly close the session with this example. See here, there is a reimbursement process happening in an insurance company or somewhere, and customer expect the refund to be processed in less than 30 minutes. That means what is the upper specification limit?
30 minutes.
Lower specification limit is 0.
0.
The earlier, the better. Now, data is available about various reimbursement claims. According to the data, the mean transaction time is 22 minutes. Standard deviation is 5.9. I want to understand the CP/CPK so that I can comment about the capability of the process to reimburse the claim in less than 30 minutes, right? So I calculate CP. You see here formula, USL minus LSL by 3 sigma. You know USL, you know LSL, you know sigma. Sigma is here, straight away given. So CP equal to 0.838. Now all of you, what do you understand here? Looking at a CP value of 0.8, lesser than 1.
Less capable.
Process is not capable, not consistent.
Not capable.
Not capable, not consistent. I can clearly say they are not at all able to meet the requirement because their CP is not even 1. Now CPK, I calculate CPK. You all know the formula, minimum of CP upper, CP lower. So CP upper calculated 0.4, CP lower calculated 1.2. Out of the two, which one you should take?
1.23.
0.4.
0.4.
Minimum only.
0.44.
Process is shifted to the right side, your capability reduced on the right side. So 0.442. So now CPK equal to 0.442. That is telling you that your process is clearly
Assistant
not.
and incapable.
Since CP is also under trouble, CPK also under trouble, you can understand both of your statistics are under trouble. One statistics is average, other statistics is standard deviation. How can you correct the average? You move the mean closer to the target. How can you correct the standard deviation? You reduce the variation. This is the statistical remedy. This is the statistical remedy. Imagine we expect the class average, the Six Sigma Bell's average performance in the mark to be 80%. But you all passed the exam, but then you passed in a border, all of you. Your average is only 65. What is our target? To make you score above 80%. But finally, we ended up getting an average of 65. Now my process is shifted towards left. Can you see? My process is shifted towards left because process average, X bar is 65 marks. I want to see the X bar at least above 80. Now tell me what should I do to shift the average towards 80? What should I do? Come on. What we need to do as a team so that we all can move the mean closer to the target.
Higher marks.
Higher? Come again?
Marks.
Higher? Yeah,
Higher
you
marks.
score more marks. Scoring more
marks, yeah.
is the output, right? So what we need to do, let us talk in terms of X now. You all have to study more. We all have to teach more. Mock exams, you all have to take it several times. Yes or no? An extra mentorship session, more focus on the exam, questions, etc. Now what happened? The class average will move upward. This is called moving the mean. So what needs to be done to move the average in your workplace? You know better than us. Am I right? But statistically
Yes.
speaking, move the mean. But practically speaking, according to the process, you have to suggest. Now, another thing, reduce variation. How can we reduce variation in the examination process? Attendance is compulsory for all the students. Am I right? If I say attendance is compulsory for all the students, all the sessions, do you think the chance of variation can come down? Yes or no?
Yes.
Made possible.
So if some students don't, let's say, no, they are not sitting in the class, then obviously there is a chance that they can score low. We want everybody to have the same experience. That means lot of standardization has to happen. Clear? And
Yes.
that has to be followed. Lot of standardization must happen. That has to be followed. Now all of you understand the meaning of moving the mean close to target and reducing the variation?
Yes, sir.
Yes?
Yes, sir.
Yes.
Now in your problem, you can decide. Similarly, different situation. This is electronic manufacturing process. Current flow should be 100 plus or minus 10 milliampere. That means upper spec is 110, lower spec is 90, process average is 107, process standard deviation is 1.5. Will you be able to calculate CP and CPK?
Yes, sir.
Yes.
Yes.
The sigma level calculator file which I gave has this formula also. You can simply type and then get the result. So CP equal to 2.22, CPK is equal to 0.66. Now, what is your conclusion? If I ask you, is this process capable? Tell me, is this process capable?
No.
Yes, sir.
Not capable, sir.
No.
Not capable. That means failure will happen. I ask another question. Is this process consistent?
Yes, sir.
No, sir.
Consistent but not
Yes.
capable.
Consistent.
Process is consistent but not capable. Now, what should you do in this case? Do you want to move the mean as well as reduce variation? Consistent means standardization is not a problem, isn't it? But capability is a problem. So only remedy required is move the mean close to target. You don't have to suggest, reduce the variation. Similarly, another case, CPK is 0.66, CP equal to 1.11. Now, what is the remedy?
Consistent, not
You have to move the mean.
not capable.
You have to meet the mean because CP are not capable because CPK is under trouble, so move the mean. CP is also under trouble, so reduce the variation. Understand all of you? This is called statistical remedy. But how to achieve it? We need to work on the process. Now, what is your recommendation here? CP equal to 0.94, CPK equal to 0.33. Now, what is your recommendation? Statistical recommendation.
Move the mean and reduce variation.
Reduce the variation and the mean. Move the mean.
Very good. Move the mean and reduce. So, this is called process capability analysis. You have already studied traditional yield, first pass yield, rolled throughput yield, and now that you studied CP and CPK. But in order to calculate CP and CPK, you need data. You need accurate data, right? And first pass yield is the probability that the process can produce the output without making any defects and without doing any rework. So first pass yield is a metric better than traditional yield. DPMO stands for defects per million opportunity. CP compares the width of the process with the width of the specification. But CPK makes use of the process average in addition to comparing the spread. So that's why CPK is superior. For any critical process, CPK must be more than 1.67. For any non-critical process, CPK must be more than 1.33. Always you should try to reach your ultimate potential. The ultimate potential, when you are operating at your ultimate potential, CP will be equal to CPK. Whenever you see CP and CPK different, that means there is further scope for improvement exists. That's it. So any questions?
Just a quick question. In the examples what you said, there is no consideration of process being critical or non-critical, but just based on CP value and CPK value, we are just mentioning that we have to move the mean or we have to reduce the variation, right? So how are we deciding on that? In practical scenario, obviously you need to look at whether the process is critical, non-critical, right?
No. See, I have explained it already while explaining the concept. I have explained how to understand the process is critical or not critical, right? So see, you need to have an understanding on your CTQs, isn't it? Not all CTQs are important. Am I right?
Yeah.
Yes.
If the customer is very sensitive to certain CTQ, that means that's a critical CTQ. Suppose if the component you produce that goes into aircraft engine, then your component may be a small nut, but it becomes very critical, isn't it? Because application is used in a aircraft engine. If I use it in my in my bathroom door, the same nut, if the nut got some damage, the criticality is less. Can you see that?
Yes.
So if you understand the application, if you actually know the reality, what kind of product, what kind of service, where it is used, what will be the customer experience? If a failure happens, can the customer be tolerative to a certain extent or the customer be very sensitive? You can define into at least two categories. See, we want you to be capable, but unnecessarily you don't have to pump in your resources in unnecessary areas, isn't it? So we always see,
Overprocess.
understand the criticality. Critical and less critical. Car painting process. All the outer surface, it is critical, isn't it?
Yes.
Under chassis, not critical. Have you ever seen the painted surface of your car under the chassis?
No.
Yes.
You're using it for the last 5 years. You never bothered to see how was the painting done. There, such a capability is not required. But even a small scratch on the outer body, you will be dissatisfied. So critical and less critical, you need to understand. And what is the other thing you said, Justin? Physical.
No, critical versus non-critical.
Physical?
No, the answer what you mentioned actually clarifies the critical versus non-critical process. That's how we define this. That was one of the selection parameter. How would we go
Correct.
for CP versus CPK? Because that was what it is mentioning, less than
Correct.
1.67 and the other
Correct.
parameter what it mentioned.
Correct. And we are giving suggestions, only statistical suggestion. You need to understand.
Yep, got it.
If you want to talk in terms of the real solution,
Mhm.
then you have to go to the field and then suggest, isn't it? For example, if you want to lead a healthy life, I will only tell, keep your body parameters in a normal range. That is a general solution, statistical solution. But what's exactly going wrong, whether it is sugar level or cholesterol, or is it your what they call WBC count, so many things. So real suggestion can come only after understanding the problem nature and the process behind, isn't it?
Yes.
But referring to the data, we can only talk statistically. Statistically, you are expected to bring the average to a particular level. But how come the average will come? Average depends on data. Data depends on process. Process depends on all the inputs. So if you optimize the input, process will optimize. Then data will optimize. Then statistics will optimize. You will start seeing your average closer to the target. Am I right?
Yes.
If you eat healthy food, your sugar level will automatically come inside the normal range. All right. So statistically we can suggest immediately, but practical suggestion if you want to make, you have to work in the real time. Go to the company without visiting the company, without seeing the patient, without understanding the problem. We can't comment, right? So that's how it is. Hope it is understood by all of you.